Okay, so I'm recording this in a deserted old church in Heptonstall, northern England. So as you can see, I'm getting around. Okay, so the topic of today is the inference forms. Now what these are is a set of 9 little arguments. That is, they're 9 arguments that are obviously valid. That we don't have to explain why they're valid, it's just supposed to be self-evident. And this is going to be true for at least 7 of them, and we'll say a bit more about the last 2 when we get there, because they're less obvious. But the point of these 9 little arguments is because we're going to use them as part of what's called giving a proof. And that's something we're going to get to in the next class, actually practicing giving proofs. But to be able to give proofs, what a proof is it demonstrates how, if you start from the premise of an argument, you can arrive at the conclusion in little steps, each of which is obviously a valid step. And if you can do that, you have demonstrated why it is that the premises guarantee the conclusion. You've shown why an argument is valid. Now, you might wonder why we need to do this, because, after all, we already have the shortcut method test for validity. Well, that tells you whether or not something is valid, but it doesn't really tell you why something is valid. It doesn't really take you from the premises step by step until you get to the conclusion. And there's a definite value in doing that. As I will demonstrate, I will give you an example of an argument where most people would agree with the premises and most people would not agree with the conclusion. So if you're going to say, but it's a valid argument, if you agree with the premises, you have to agree with the conclusion, it really helps to demonstrate how it is that the premises lead to the conclusion. And that's what a proof does. So to be able to do a proof, and we're going to be doing a lot of them, and you'll either love them or hate them, we need to know these basic rules. There are actually 19 of them, but we're going to start with the 9 rules of inference forms. And actually, if you look inside the front cover of your textbook, you'll see that they're printed there, right on the cover. They give you the inference forms. Okay, so let's look at them. The first inference form that we'll look at is simplification. Now, I'm going to illustrate simplification like this, using shapes. And I'll explain why that is in a moment. In the book, you'll see that it's like P and Q, conclusion P, or P and Q, conclusion Q. But I'm going to use shapes because when you just use single letters, it's easy to get the impression that it only works on something that is a simple conjunction, where it's just P and Q or A and B. And that's not the case. You can use simplification on any conjunction, and you'll need to. Okay, this one should be very intuitively obvious. If it's the case that today is Wednesday and this is Heptonstall, well then you know it is the case that today is Wednesday. Or if it's today is Wednesday and this is Heptonstall, you know it's the case that this is Heptonstall. That just should be mind-blowingly obvious. So that's why you don't really need to justify simplification. It's just obviously correct. Okay, so why am I using shapes instead of letters? Well, because this, for example, is an example of simplification in action. As you can see, we've got a long, ugly compound proposition there, and you can simplify the half of it. So notice I've put the conjunction in red so you can see which one I'm simplifying. And this is what results on the bottom. Now, I actually made a mistake in that I included the square brackets. They're included up here, but you only need them to illustrate that the conjunction is the main connective. Whereas here, now the conjunction is not the main connective, and you never need to have brackets around the entire line. So that's why I've scribbled them out. You wouldn't need them. Now you've got something where the conditional is the main connective. Okay, so that's simplification. Easy. Pretty much just as easy, in fact, simplification in reverse is conjunction. And that's where you have a 2-premise argument where you have something on one line, something on the next line, and then you just glue them together with a conjunction. so if you know that today is Wednesday and you also know that this is Heptonstall, you know that today is Wednesday and this is Heptonstall. And you can work this out from a truth table, because if it's alone on a line, we assume that it's true, it's being asserted. So if you know one is true and you know the other one is true, well then that proves that the conjunction is true, because those are the truth conditions for a true conjunction, when both the conjuncts are true. A couple of points before I go on to any other inference forms. Rules of inference have to be applied to an entire line. So, for example, you can't just do a conjunction to a bit of a line. So, for example, in this one, you couldn't, or look here, you've got a conjunction right there. You've got a conjunction there. Can you do simplification to that conjunction? No, you can't. You can only do simplification when conjunction is the main connective, as it is here. But once you're down here, you can't do simplification anymore, because the main connective, the main truth function, is the conditional. So you can only do simplification when conjunction is the main connective of the whole line. That's important. That's the difference, actually, between the inference forms and the rules of equivalence, which is why they're separated. But we're just doing inference forms today. All right, I'm going to take a break.